My name is Creighton Kumar, and today I'm going to be talking about the second fundamental theorem of calculus. So, let f be continuous on a to b. Then, if this is true, we can say that the derivative of the integral from a to x of f of t dt is equal to f of x. Well, this is just a formula, or a saying, of how we can use the second fundamental theorem of calculus to solve problems where we have to find the derivative of integrals. This is just the basic form. However, there are more intricate ways that we can find and solve problems like this. In order to solve for problems related to the second fundamental theorem of calculus, you need to know these formulas here. Well, the first formula we've seen before. And in order to solve this formula, or use it, we have to make sure that the lower limit is a constant and the upper limit is a variable. If that is true, all we need to do is, if it is in that position, we just take the upper limit, which is a variable, or our x, and we just plug it into our values of t. Into that, and we get, in this case, f of x. The second formula shows that the derivative from a to u of x, f of t dt, is equal to u prime of x, f of u of x. We can say that it is almost the same as the first formula, but the second formula is different because it implies the use of chain rule. The third formula simply states that if I have the derivative of the lower limit of v of x and the upper limit is b, I have to make sure that the lower limit is a constant and the upper limit is a variable. So I can just flip it, and when I flip it, I have to add a negative sign in front. When I do that, I just simply solve. Before I go to the fourth formula, I have a side note written down here. It says that if I have two variables, what I need to do is, I cannot solve for it directly, so I need to separate the integral and then solve for it. So, we have to find the derivative. We separate it, as we see it right here, and we take the derivative to these. And after that, all we do is use the chain rule and all the other stuff we have using the first three formulas, and continue and solve and simplify to get what we have here. Here, I have some practice problems related to the formulas we just saw, so give them a try and see how you do. 3, 2, 1. Before we start, for all of these problems, you want to make sure that you look at the lower limit and the upper limit. Based on that, you can do what you need to do, work around the formulas, and get it to a settable location from where you can solve it. So from here, we're just going to act like we know what we're doing. So since the constant is in the lower limit and the variables in the upper limit, it is already in our set location. So what we do is we take x and plug it in all the values of t. So all we do is take x, plug it into t, and we get g prime of t is x squared minus 1, all raised to the power of 20. So we see that the lower limit is a variable. So what we need to do is we need to make sure that we flip it. So when we flip it, we get a negative in front, and we flip it. And after we flip it, we see that the x is on the upper limit. So now we just take the x and we plug it into t's. And after we do that, we just simplify. So again, look at the lower and upper limits, then continue the problem. So right here, we see that what we need to do is, since this is a constant and this is a variable, we take our variable and plug it in all the values of t. That's what we get here. But we need to use chain rule. So we take the derivative of 2x and we simplify to get this. Double check your lower and upper limit. Once you've done that, do what you need to do to get it to a settable way so that you can solve the problem. So now we're going to flip it, add the negative sign. Using the chain rule, what we're going to do is first we're going to plug it in to the values of t, which we have here. Take the derivative of 3x squared, and remember to carry over the negative sign. What we do is we just find the final answer as negative 6x e to the power of 3x squared minus 3. Number 5 is a tricky one. This is because the lower and upper limit are the same. Whenever it is same, we know that this answer will always be 0. Because if we took the integral separately, that would equal to 0. And if we took the derivative of the integral, that too will be 0. You can go about this the long way and find that if we took the derivative of this, we will also get 0 in the end. Question 6 involves multiple steps. So, what we do is remember to use the chain rule. So we take our x squared and plug it in all the values of t, or in this case, just 1, right there. What we do, after that, we take the derivative of x squared. Simplify, and this is what I get over here. But the question is not answering what is g prime of x, it's asking g prime of 5. Like the other problems, it would be like, oh, what's h prime of x, or what's g prime of x, or what's k prime of x. This one's actually asking for a number, so this is kind of tricky. So what we have to do, after we get g prime of x, we just plug in 5, and we simplify to get 65 over 313. Here is another set of 2 problems. These are a bit on the challenging side, so give it a try and see how you do. 3, 2, 1. So, for number 7, we see that this time it's not dt or anything involving t's. So, don't get tricked by that. What we still need to do is, whatever it is, we just take the square root of x and plug it into the values of v, which we get here. Remember to incorporate the chain rule. So we take the derivative of x to the power of 1/2. Whatever we get is here, and after a little bit of simplifying, this is our final answer. Number 8 is one of the harder problems we have in this practice. Well, we see that the lower and upper limits are actually variables. So, how are we supposed to solve this? Well, remember, if we have an integral, we can always separate it. So, I just drew a sketch. So this is from a to b, so a to b right here. And then I said from a to c of whatever this function is. So a to c is this blue shaded region. And I said c to b is this region. So I said that these two add up to this. So if we keep that in mind, all we need to do is remember this and separate it into 2 different integrals. So from what we have over here, x squared as the upper limit and tan x as the lower limit, we just separate it. So the lower limit here is just tan x. I put 0 as my constant, and it could be any constant. And same thing here. I put 0 as my constant, and the upper limit is x squared. Then I just go about solving these as 2 separate integrals. Remember, since the variables are in the lower limit, then what we need to do is flip it and add negative sign. Then, since we already know how to do this, we just plug it in and use the chain rule. Same thing here, plug it in, use the chain rule, and simplify to get this as our final answer. So, some common mistakes people always forget is not using the formulas correctly or forgetting them. Sometimes they don't look at what the question is asking. Suppose they're looking at, oh, what's g prime of x, or instead of g prime of 5. And sometimes they don't check the lower and upper limits before they start the problem. That is a big problem, because if you don't do that, then you don't know how to set it up in order to solve the problem. Also, just not multiplying the derivative of the upper limit or using the chain rule properly could also affect not getting the right answer. Any arithmetic mistakes could also be part of this, and just accidentally combining the upper and lower limit if they both are variables instead of separating them. That is a big thing. Some tips to help you in using the second fundamental theorem of calculus is memorizing the formulas, looking at what the question is asking, doing practice, and thinking of how you're going to solve the problem before you actually start. If you need extra practice, look at my worksheet, and thanks for watching.